Hello, everyone. My name is Karen Corletto. I lead a team of undergrad students. We work in Dr. Erin Giles' lab in the Department of Nutrition. And our research focuses on looking at the effects of obesity on postmenopausal breast cancer. Today, two of our students will be presenting the preliminary results of an exercise study. And our title today is The Effects of Endurance Exercise on Tumor Growth in a Rodent Model of Postmenopausal Breast Cancer. So today, Anuya Kata and Abigail Kelling will be presenting this poster for you.
Thank you, Karen. So prior to performing this study, we were able to gather information on what is already known. We currently know that obesity and physical activity have been linked to an increased risk of postmenopausal breast cancer. We also know that more than 70% of the United States population is considered overweight or obese. When combining this with the postmenopausal state, there's about a twofold increase in the risk of breast cancer. Previous studies have shown that more than 50% of individuals in the US fail to meet the daily physical activity recommendations. Exercise has the potential to decrease cancer risk or improve outcomes in postmenopausal women, though the specific mechanisms for cancer prevention are unknown. Menopause is known to be a critical factor in the relationship between obesity and breast cancer. Prior to menopause, obesity has little to no contribution in increasing the risk of cancer. However, in a postmenopausal state, the adverse effects of obesity begin to emerge. The goal of this study is to determine the mechanisms by which endurance exercise decreases tumor growth. So if we look at the box below, we have a model from a previous study that highlights the relationship between rats and humans. In figure 1A, you can see that ovariectomies induced a period of rapid weight gain in all of the animals despite their body weights. Right below, in figure 1B, you can see that the obese rats had fewer tumors regress, more tumors progress, and more new tumors emerge altogether. When challenged with an excess caloric intake, it was found that the mammary tissue in the lean rats adapted to the excess energy, while their tumors did not, and the contrary was found for the obese rats. With the information we gathered from the previous study, in the top box here, we can see that we hypothesize that the beneficial effects of exercise on tumor growth will be due to both the improvements in obesity-associated metabolism and direct effects on the tumor and its microenvironment. In this chart on the left, you can see that we used female Wistar rats and injected them with a carcinogen, methylnitrosourea, around 7 weeks, and that was to induce mammary tumor formation. They were fed a high-fat diet with limited physical activity to promote obesity. Around 18 weeks of age, obese and lean rats were selected based on their percent body fat, and the tumor-bearing rats were overreactomized to model menopause when a tumor reached about 1 cubic centimeter. At the time of the ovariectomy, rats were randomized to either an 8-week exercise intervention group with a treadmill or a sedentary group. Within the exercise group, rats ran about 15 meters per minute to total 60 minutes a day, and this was done 5 days out of the week with non-consecutive days off. A 10-point scale was used to measure compliance and motivation. And with that, I'm going to pass it off to Anuya.
So our first two graphs here in the results section really just highlight how we made that distinction between obese and lean rats. So if you look at body weight, you can kind of see the gap between the two groups widen as the rats grow older, and you see that same difference in body fat percentage, but even to a greater extent, which is why we used it to make the distinction. Next, we take a look at the results post-OVX, which is where we usually see a period of rapid weight gain. Not only do we still see that in both exercise groups, but there's also no significant difference between the sedentary and exercise post-OVX weight gain. The obese exercise group is slightly lower on the weight gain curve than the sedentary, but it's not really enough to be significant. And then when we look at body fat percentages, we see those same results. When we turned our attention to more specific types of fat, gonadal, mesentery, liver, if there was maybe some difference there, we couldn't find any consistent significant differences between the two groups. So instead, we shifted our attention to the plasma metabolites, hoping for some kind of indicator on a difference induced in whole body metabolic health. But for the most part, we didn't see much difference here either. They all had similar levels of circulating glucose, similar levels of insulin resistance, no difference really with non-esterified fatty acids or triglycerides, or even with IGF-1. We did see a significant difference in cholesterol between the obese sedentary and obese exercise groups, but this was a little confusing since the obese exercise group had a higher cholesterol than the obese sedentary group, whereas the lean exercise group had the lowest cholesterol of all. So we ended up concluding that maybe the lack of effect of both obesity and exercise on metabolites had something to do with the fact that the rats were all on a high-fat diet and they were all undergoing that rapid post-OVX weight gain, so that might have masked any effects temporarily. So our takeaway conclusions from this preliminary study that we had ended up being that endurance exercise alone wasn't really enough to suppress that post-OVX weight gain, and it didn't seem like exercise had a strong effect on body composition or whole body metabolic health, so we still need to work on determining the way that it managed to decrease tumor growth in some of our rats. So this is still an ongoing study, so we do still have a lot of histology to work through and a lot of other avenues to explore. For example, we can look at whether it has a more area-specific response by looking at tumor microenvironment, or we can look at other whole body responses. And eventually, we hope to determine the mechanisms by which exercise affects tumor growth, and thus determine the optimal routine by which to suppress mammary tumor growth. And that concludes our preliminary analysis.